Welcome to Chapter 7, Section 5, entitled Sample Spaces. First off, a set of all possible outcomes is called the sample space. And a tree diagram is a diagram that shows all possible outcomes of an event. So you basically start with the first possibility and then show how that works with, it goes on from there. So while on vacation, Carlos can go snorkeling, boating, and paragliding. In how many ways can Carlos do the three activities? Make an organized list to show the sample space. So we need to know how many ways they can do the activity. So you can of course do snorkeling, boating, and paragliding. Or you can start with boating, do paragliding, and then snorkel. Well, actually, there's a better way to set this up. Instead of doing that, use S again. So SBP or SPB. Right? Those are all the possibilities of doing snorkeling first. Then go to boating. Boating, and then do snorkeling, parasailing. And do once again boating first, but switch the other two events. And lastly, if you put paragliding first, you could go paragliding, snorkeling, boating, or paragliding, boating, snorkeling. So there are 1, 2, 3, 4, 5, 6 possible event orders. All right, these Ken, Betsy, Sally, David are seated in a row at the head table at a student council meeting. In how many ways can the 4 students be seated? So we're making an organized list. We're going to let this be Ken, Betsy, Sally, and David. And let's put it in that order first. And now let's leave, to make this organized, we need to leave Ken as the first person. And we'll put Betsy at the end. So S, D, E. And then Ken is the first, D, B, S. And those are the 3 possibilities with Ken being first. So let's make possibility with Betsy being first. So B, K, S, D. B, S, D, K. And B, D, K, S. So that's with Betsy being first. And we just keep making these lists. All right, well, let's Sally be first. So Sally, and it doesn't really matter what's next. Sally, KBD. Because Sally's first again, and we're moving Ken to the end. BDK. SDKB. So that was with Sally being first. And then the last row here, we're going to have David be first. KBS. David is first, and Ken is last, so that's BSK. And then David is first with SKB. So that's with David being first. So the reason we do this as an organized list is because that way we know for a fact that all of our choices have been selected. If we did a random list, it'd be a lot of work to make sure everything was covered. So now let's count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 ways in order to do this. 12. All right, using a tree diagram. All right, let's look at this. A car can be purchased with either 2 doors or 4 doors. You may also choose leather, fabric, or vinyl seats. Use a diagram to find all the buying options. All right, so we're using, this is a tree turned on its side. List each choice for the number of doors. So you can have 2 doors or 4 doors. Then pair each choice for the number of doors with each choice for the types of seats. So the seats are leather, fabric, or vinyl. Leather, fabric, vinyl. So now you can set these up so that this is the 1, 2, 3, 4, 5, 6 possible buying options. There are no other ways we can organize this, and this will help you with your organization. Please remember, when you're doing this, that outcomes are all the possible results of a probability event. So, a pair of sneakers can be purchased with either laces or Velcro. You may choose white, gray, or black and use a tree diagram. So we have to start with our first choice, laces or Velcro. And if you choose laces, you then have 3 more choices, white, gray, or black. Velcro, you have 3 choices, white, gray, or black. So use a diagram to find how many different sneakers are possible. Well, there's one possibility, 2, 3, 4, 5, 6. There are 6 possible choices for sneakers. All right, that's using a tree diagram. The fundamental counting principle states that if there are blank outcomes for the first choice and blank outcomes for the second choice, that the total number of possible outcomes is m times n. Okay, so this is a probability of a certain thing happening. If there is a m outcomes for the first choice. So for this one here, there were 2 outcomes. And if there are n outcomes for the second choice, so right here there are 3 choices, then the total number of possible outcomes is m times n. 2 times 3 equals 6. So this helps us now because we could go back to this right here and say we have 2 outcomes here, 3 outcomes here, 2 times 3 is 6. Or this one. There are I guess this one wouldn't be able to happen. All right. So let's look here. Chloe wants to buy a bouquet of flowers and a vase. The flower shop has roses, daffodils, and tulips, and has 4 different vases for which to choose. Use a fundamental counting principle to find the total number of possible outcomes of a bouquet made up of 2 types of flowers in a vase. So what is the number of outcomes for flower choices? Flower choices. 1, 2, 3. There are 3 choices for flowers. Number of outcomes for vase choices. There are 4 different vases. 3 times 4 is 12. That means you have 12 possible outcomes. All right, let's take a look here. The restaurant offers a pasta bar. Customers can choose fettuccine, linguine, and macaroni with 3 types of sauces. So the probability or the outcome of the type of pasta was 3 times the number of sauces is 3. That equals 9 possible different combinations of food. All right, so that's it for sample spaces. You need to do your CYUs on pages 391. Exercises 1, 2, 3. All. Good luck. Oh, And again, this is our classwork. This is what work we will be doing in class.